Okay, let's take a look at problem 1, modeling exponential growth. Since 2005, the amount of money spent at restaurants in the United States has increased by 7% each year. In 2005, about $360 billion was spent at restaurants. If the trend continues, about how much will be spent at restaurants in 2015? So let's first take a look at exponential growth and decay. And for exponential growth, it can be modeled by the function a times b to the x, where a has to be greater than 0 and b has to be greater than 1. And so a is my initial amount when x is 0, and b, which is greater than 1, is my growth factor. So let's go ahead and apply that to this equation. So it says, let x be the number of years since 2005. And so at 2005, it'll be x equal to 0. So our initial amount then would be this $360 billion. And that's A. A is the initial amount, 360, and it says in billions of dollars. Y is the annual amount spent in billions of dollars. And B will be the growth factor. And since I'm talking about growth, I'm going to add 1 to it. So it's going to be 1 for 100% plus 0.07. And I'm changing this percent to a decimal form. And so my equation will be y equals 360 times 1.07 to the x power. Then it says use the equation to predict the annual spending on 2015. Well, when I plug this into my equation, I get 708. And remember, we're talking about billions of dollars. This would be $708 billion. And it says, what is an expression that represents the equivalent monthly increase of spending in restaurants? So now we're talking about monthly. So at first, if you remember, it tells us each year. And so now we want to do monthly. So it says you will need to find an expression of the form r to the m, where r is approximately the monthly growth factor and m is the number of months. You know that 1.07 represents the yearly increase, where x is the number of years. So we put 1.07, and we're going to raise this to the 12 over x power. All right, so when the power is raised, I get the 12. So this is going to be multiplied through. So I get 1.057 to the 12x power. And so that means that my monthly would be 1.0057 to the m. So that would be the equivalent m for 12m. All right, let's go on to the got it. Okay, I'm sorry about that. I had to get my notes. Okay, it says, suppose that in 1985, there were 285 cell phone subscribers in a small town. The number of subscribers increased by 75% each year after 1985. How many cell phone subscribers were in the small town in 1994? Write an expression to represent the equivalent monthly cell phone subscription increase. So first, we're going to do this part. And so we're going to do it just like they did here. So we'll say x So x is number of years since 1985. Okay. Y, of course, would be the number of subscribers annually. All right. A is our initial amount, and they gave us 285 as our initial amount. B will be our percent increase. So it started off at 75%. So we're going to add 100% to that because it's an increase, and we get 1.75. And our equation that we get is y equals 285 times 1.75 to the x power. Now, they want us to find it from 1994. So 1994 minus 1985 is 9. So I'm going to plug in 9. So 285 times 1.75 raised to the 9th power. So I'm going to put that in my calculator. So 1.75 raised to the 9th power times 285 gives me 43,871.986. I'm going to round it up, and I get 43,872 subscribers since 1985. So for the 9 years. Now I need some space here. I want to write an expression to represent the equivalent monthly cell phone subscription increase. So same concept. I know that I started off with 1.75 and raised to the x, but this time I want it to be instead of for the year, I want it to be for the month. So there's 12 months in a year. So I'm going to do 1.75. So 12 over 12x. And so I get 1.75 to the 1 over 12 because I'm raising it to that I'm raising it to the 1/12th power. And let's see what that is. So 1.75 raised to the, put in parentheses, 1 divided by 12. And I get 1.047 or 1.05. So I get 1.05 raised to the 12x. And instead of 12x, we'll say 12x, like they did, is equal to m. So I'll say 1.05 to the m. All right, I hope this helps.